The combination of mathematics and English was carefully chosen because considered particularly appropriate at an early stage of the secondary school teaching process. The advantage of this choice can be found in the fact that mathematics, to a large extent, excludes the possibility of various misinterpretations. Its accuracy, if well looked after, makes the input intelligible to the student and usually avoid formalisms and verbalisms.
Okay, so we have analyzed the behavior of the quadratic fractions graph by looking at A, B, and C questions. So now we want to analyze what happens when A, B, and C changes. And I want that you tell us what you have come to as a conclusion. For example, Mr. Terza, let's go to the blackboard and tell us what you see using the computer.
Okay. So, I'll study the coefficient A right now. So we have three cases when A is equal to 0, A is more than 0, and A is less than 0. In the first case, we have a first degree equation, so the graph will come to us as a line, not a parabola, because we don't have the x squared. When A is greater than 0, our parabola will open upwards. So it will be like this. When A is less than 0, our parabola will head downwards. Now, the opening of the parabola depends also on how A is greater. If much A is greater, the narrower the parabola will be on the y-axis. So that's what I managed to understand from our graphics.
Yes, it's right. Okay. And someone speak about B. Mrs. Classe, please.
Well, one thing that we know for certain is that B is linked with the position of the vertex.
Mm-hmm.
So, in particular, if our parabola opens upwards, which means, as my fellow student told us, that A is more than 0, the vertex is the point of minimum.
Yes.
Whereas if the parabola opens downwards, which means that A is less than 0, our vertex is the point of maximum. Okay, but for a better understanding of how B influences the plotting of the graph, we have to solve a simultaneous equation, which is this: y equals ax squared plus b times x plus c, and y equals 0. We will find that we are solving a second degree equation, and we will have, if delta is positive, we will have two real solutions, x1 and x2, which represent the intersection points of the parabola with the x-axis. So, in our case, in this case, the x-coordinate of the vertex is the mean between the two solutions, which means that x of the vertex is equal to x1 plus x2 divided by 2, which is also equal to b over minus b over 2a.
Okay, if we...
Yes?
No, okay, perfect.
Perfect. Okay. But if delta is equal to 0, we will have two coinciding solutions. So x1 is equal to x2, which means that our parabola will intersect the x-axis in only one point. For example, this one here. If delta instead is less than 0, then there will be no intersection points because we don't have real solutions. Which means that our parabola will be either entirely up above the x-axis or entirely under the x-axis. Okay. Is that it?
Yes, perfect.
Okay.
Let's see something about C. Mr. Trabocchia, please.
Yes. So, to study the behavior of C, we must investigate on the intersection of the parabola with the y-axis. This one.
Okay.
This is the solution to this. Y equal to a x squared plus b x squared, now x, plus c, with x equal to 0. The solution to this is at the point 0, c. So, c represents always the point where the parabola meets the y-axis.
Okay, perfect. That's all, I think.
Yes.
As you can see, clearly it's an innovative approach to learning, a dynamic and motivating force with holistic features. It constitutes an attempt to overcome the restraint of traditional school curricula and represent a shift toward curricular integration.